Exploration versus exploitation. We must embrace mistakes and not view them as a threat. We see this in the classic exploration versus exploitation problem, described as early as 1952 by Herbert Robbins. Take reinforcement learning. This is one of the four categories of AI and immediately the least known, but perhaps the most interesting. This is an algorithm that starts from a starting point and attempts to move toward a goal, learning a bit like children do. Behavior yields a result that is rewarded negatively or positively. When training a model, the AI engine tries to get further and further. If a route is promising, it is reinforced. If a route does not work, the system tries another. Eventually, a route is found, but that does not mean that the found route is the most efficient. Sometimes you have to deliberately introduce a mistake to force the model to explore a new path. That is actually a rudimentary form of thinking outside the box. Mistakes create efficiency, an early example of what Nassim Taleb would later call antifragility. Therefore, we must view hallucinations not only as a problem, but also as a source of creativity and variation. LLMs hallucinate always, not sometimes. They provide a probable answer, not an absolute one. Usually that answer is reasonably accurate, sometimes it is not, and then we call that a hallucination. To compensate for this probabilistic nature, it is wise to ask the same question multiple times. The chance of a hallucination repeating itself is small. Through variation in the answers, we learn better how an LLM reasons, and we can interpret the results better. AI and statistics therefore share the same philosophy, working with uncertainty, approximation, and probability. Whoever understands that understands the core of how AI thinks.